data becomes vulnerable when you have to send it, when you have to transmit it, or when you have to process it.
Transparency is one of the core tenets of blockchain and crypto, yet privacy is one of the issues which prevents wider adoption of crypto, say for example with institutional adoption. How do you preserve transparency yet introduce privacy? And that's one of the problems that today's guest on Alpha Unhashed is trying to fix. Christian, co-founder of Mind Networks, is addressing this problem with FHE, Fully Homomorphic Encryption. I'm Sri Misra, your host for Alpha Unhashed. Chris, welcome to Alpha Unhashed.
Thanks so much for having me, Sri. How are you today?
Very well, thank you. And how are you? And whereabouts are you?
I'm well, thanks. I'm based in the States on the East Coast, currently in DC, where there's a lot of activity happening right now.
Yeah, I can understand. Yeah. So it's the morning for you, and it's quite late evening for me out here in Singapore. And I'm looking forward to, an amazing conversation. One of the best things I like about doing Alpha Unhashed is I get to learn so many new things and get to dive deep into, these conversations. And that's what sort of Unhashed is designed to be. So, Chris, what is FHE?
So fully homomorphic encryption is an encryption method, and it was conceived in academia in 1979, and it was conceived as sort of this potential to be the holy grail of cryptography, because data becomes vulnerable when you have to send it, when you have to transmit it, or when you have to process it. We've had encryption methods for stored data for quite some time, but storage was not the leakiest capacity in which data resides. It's usually it's very vulnerable to attack when you have to send it, when you have to process it. So we've been decrypting data for sending and processing for decades. And then in 2009, the folks that were sequencing the human genome and doing work there, realizing that human genomic data is highly sensitive, perhaps the most sensitive data. You can't get a new genome. And if that leaks, there are terrible potential that bad actors could use that for. Think things like biohacking or being able to use your tamper with medical data and all the things that you could sell that for in the dark web. It actually had a real application here, and so that was the first time we saw it used in sort of a commercial capacity. And since then, it's just been scaling and scaling. And so it is this kind of like it's like the King Kong of encryption methods, because it's the ability to encrypt data during storage, during transmission, and during processing, and never having to decrypt it, which obviously reduces the attack vectors massively. So the problem with it is that it's been too slow for most applications for the last 15, 16 years. In the last several years, it's become very promising. In 2021, we saw kind of a wave of FHE development. Intel, Microsoft, Google have FHE departments. They have small teams that are working on this to increase the security on the server side. But we haven't had anything that would look like it was going to deliver FHE to the users around the world who are interested in protecting their data, maybe locally, or having access to using FHE to turn on and off data sharing, or putting parameters around what kind of data they want to protect and how they can monetize it. So FHE built in crypto is this real dream come true, and it spells out it leads to potential for the usage of the internet by individual users that we almost can't even imagine. That was sort of conceived maybe in the early 90s in Web 1.0. This was kind of what the original developers of the internet were thinking of. Now, this is a key technology in delivering that vision.
That's very interesting to learn about the origin, and we'll get into that. I know a bit of your background intersects as well. I understand you come from a medical background.
Correct. Yeah. So that was my career 1.0. I spent time selling medical devices, medical technology, teaching doctors how to do surgery all around the US and around the world. And It was a more basic technology in the 2010s, and then I started getting into AI and 3D printing. That was really the frontier of medical technology and health. AI was assisting medical devices and assisting surgeons in treatment planning and executing surgery. Actually, one of the devices I sold was a laptop that you would have in the operatory next to the patient, and you would have this scan, the 3D scan of that patient, so you could see where their anatomy was while you were operating on them. So if you were drilling and you were getting close to a nerve, you wouldn't know that looking at the patient, but having their scan, the image on the laptop next to them, you could actually see, oh, I'm getting close to a nerve. Let me avoid that. So that was very helpful, and also selling 3D, some 3D printing technology, which worked really well with 3D imaging. We I worked for a startup that actually created the world's first radio opaque model, which meant we could take a 3D image of you, Sri, and we could print it with a
Hmm.
3D printer. So imagine just a picture of your mandible, and we could practice surgery on the model, which is a model of you, before we do the surgery on you. So you
Wow.
can imagine as a patient, you'd probably prefer that. So the doctor can do that over and over. He can practice on three, four, five models, six models, as many as he needs to get it right, throw the models away when he's done. And then he could take an image after every surgery, practice surgery. He could take an image of that model because it's radio opaque, meaning it shows up on a cone beam. So you can take a 3D image of this 3D printed model of you,
Hmm.
and you can see the anatomy. Because if you take a 3D image of plastic, nothing shows up. You have to have some metal particulate in there to reflect back, so that there's some data to read. And so this was a really cool thing. It was the first of its kind in the world. I went around selling that, and in the process of teaching doctors, and helping my CTOs, my developers develop these technologies, what I kept coming into was this problem of data availability. So in the medical sector, data is famously siloed, and it is for good reason. It's very sensitive data, but and it's also very protected. It's the most regulated data between HIPAA and GDPR. There's so many rules and things you can't do with patient data. However, if we were able to unleash this data, and this is what I kept realizing over and over again when I would hit these sort of bottlenecks in product development, if we could unleash this data, we could make AI so personalized to individual people. If we could find a way to give AI tools access to AI agents or AI systems, whatever, access to your medical records, every procedure you've ever had done, all the treatment plans that doctors have created for you and executed over the years, your personal history, your relatives, your ancestors. If there was a way to do that safely and securely, every single person would be able to access individual insights to preventative care, to treatment plans that will have the maximum beneficial outcome for them. High outcome procedures, 99% success rate. Better cancer treatments. And so this is the problem with, when healthcare meets tech, you find that tech people look at the body as sort of hardware and software, and they figure out, okay, if we can do the rights, if we can fix the software, we'll fix, if we can upgrade the hardware, or if we can fix the software. And unfortunately, like, human anatomy biology is much more complicated than that. Every individual, a treatment plan that works for you, Sri, might not work for me. And a lot of doctors won't always know why. They'll point to some research that was done, but the research is always a little bit hit or miss, because a large percentage of double-blind, placebo-controlled studies, which are the gold standard in medical research, can't be actually replicated. They're done once, and then they actually can't be done again. So there's so much kind of, I guess you'd call it mystery to why certain anatomies work different ways. And our bodies are so sophisticated and complex with how organs work with each other. So the only real way, the only real future in which AI is really helping people in a health sense is if we get customized, personalized care. But in order to do that, you have to have really secure data. Now, FHE is really promising for that. And that's how I got into FHE. Was I started speaking about these problems publicly online
Hmm.
several years ago, and just kind of, saying what I knew to be true, having kind of been in the trenches. And I ended up aligning with a team that was developing FHE technology. I'm not a PhD in AI or cryptography, but I found some really smart folks who are, and we just kind of sunk right away, like, seeing the potential of what this could do. If we don't have to decrypt data at any point, and it can remain encrypted, and if that's acceptable to regulators, we are looking at an incredibly exciting future.
Hmm. That's very interesting. But I'm just trying to kind of dig into this a little bit. Um, for the specific application you spoke about, and the limitation there, you could still use anonymized data, or even the the healthcare medical data set could also undergo some transformation before it is made publicly available for any machine learning AI training. So why would you need an FHE when you could have done either of these?
Well, yeah. So in that framework, you're still talking about a one-to-one application. So what you're describing is okay. The data is anonymized. That protects the patient, but it also doesn't allow you to deliver customized care to that patient. You actually want data to stay attached to patients, and you want to
Hmm.
compile all the data they've ever had from different companies and different healthcare providers. And this is just a healthcare scenario. So that, and anonymization is used at scale today, but it's still used by companies to sort of create this centralized delivery of products and services. It's not going to be what gets us to individual personalized care. The other issue with the framework that you're describing, which is the framework that's being used today, is that healthcare providers, tech companies, medical technology companies, and then software developers, they all get their data from their product, but they can't access data from other companies and other
Hmm.
providers. And so there's these walls up. All the data is siloed, and these companies and these healthcare providers, they're not incentivized. They're actually actively discouraged from sharing their data with anyone else. So to give you an example, the idea of data pools surfaced many years ago. What if we can create an incentives protocol that allows multiple data holders, healthcare providers, big medical device companies, pharmaceutical companies to share their data in a data pool and have it all be encrypted and anonymized, but at least you create this pool of data from which products can be developed and so on and so forth. And what we found when we try to bring that to market is that there are some entities that have a heck of a lot of data. So think of like a big insurance company. What is going to bring an insurance company into this data lake to share their data when you've got other small startups in there that have a lot more to gain? So it was really hard to make the incentive scheme equal to everyone to get them to participate. And so that's another problem that we have to solve, that this framework proposes kind of in a centralized format. It's really hard to do that.
Hmm. Okay. And Chris, how did you land up from selling advanced medical devices and technology, recognizing this as a challenge, and then bridging right into FHE and crypto?
So like I said, I saw this problem over and over again of siloed data. And I think it really came to a head in the end of 2022 as well. We saw the Twitter files, which in this country was a big deal because our data, that was the first time we really saw our data being used in sort of nefarious ways for censorship. And there was apparently this sort of back room relationship between the big tech companies and government. And 80% of most people in this country's use of the internet was through like three major platforms. It was like Google, Meta, Amazon is how most people access the internet, was through these like three apps. And so we all started to kind of see this monster we've been creating over the last 20 years. I mean, going back to, the dawn of AdWords, when Google kind of showed the world how we were going to monetize the internet. We're going to make products for free, but we're going to grab all this data, and that data is going to generate ad revenue, and ad revenue is going to be the model of the internet. So for 20 years, this monster has been slowly building, and I think most people didn't really wake up to the negative repercussions of that until we saw the Twitter files. I mean, we had plenty of data breaches before that, really big data breaches. Healthcare providers like Blue Cross Blue Shield and Yahoo and big banks, Wells Fargo, I mean, Citibank had all been hacked, and we had hundreds of millions of individual data profiles have been leaked. And so we all knew that there was definitely a security issue with data being stored, but we also now we're seeing, well, that's not the only issue. There's also this other issue of the fact that there's kind of a single or just a handful of companies to go to if you are a government interested in
Hmm.
more control, and you can kind of force your way in and coerce these companies to give you backdoor access. And so that was concerning to me. The other problem of seeing all this siloed data was concerning. And so again, I just started kind of speaking about this publicly on my social platforms and ended up getting connected with some people that were also concerned with it. And so we've got this team now that we have real uniformity of vision around this problem.
Hmm. And homomorphic encryption has been around for some time. Even fully homomorphic encryption has certain computation limitations around it. And can you delve a little bit into that?
It does, yeah. So one of the problems technically with FHE is what you're doing is it's based off lattice mathematics, which means you're taking data and you're kind of plotting it in this lattice, and so you can when you're computing upon it, there's an element called noise, which is all the potential bad computations or the bad outputs that you have to keep in there to kind of randomize and keep it secure and keep it unhackable. And the more advanced computation you do, the more noise there is, and that noise can then become counterproductive to getting accurate results. So, for an example, right now is with current hardware capability and scheme capability. If you wanted to make an FHE LLM, so where your prompts are encrypted and the data that's going back to the server, of like OpenAI, for example, or Anthropic or Gemini, is all fully encrypted, it would take somewhere between 15 and 20 minutes just to get a response on a prompt. That's obviously way too long. Um,
Mm-hmm.
but what we found is that for simple computation, it's actually performant right now. It's under a second. So for most crypto applications, that's performant. And what we've also found, and what our team has worked on, is a concept similar to what we just saw DeepSeek do. So hardware is where a lot of people have been focused in developing FHE. You have FHE chips, and so everyone looks to the hardware manufacturers to kind of scale this up. And so we're looking at hopefully 1,000x over the next 3 to 4 years in hardware capability. But like DeepSeek showed us, you don't actually have to solely rely on hardware acceleration. You can optimize the schemes as well. And so our team, one of our team members was a professor at Cambridge in cryptography, and we've optimized the scheme in house. So we've optimized the software side of it to be faster and more performant, and we're doing that all the time so that we don't have to be reliant on hardware acceleration. And so if you do this, you can actually get really, really reliant outcomes and results in really fast times on a growing amount of different kinds of computation and a variety of data. So I guess we'll get into the kinds of data that we're protecting in a moment.
Mm-hmm. Okay. The sort of coming to mind network, can you explain more about how mind network works? What are its applications specifically for, say, in areas like DeFi? uh, and and we'll get into the distinction between what's been happening in terms of identity privacy with ZK proof, for example, and versus what Mind Network and FHE could do in terms of data processing itself without needing to decrypt any encrypted data. But so in that whole spectrum, where is Mind Network? How does Mind Network operate? Is it as a protocol layer on top of blockchains? How does it all function?
Yeah, so we are an infrastructure layer. We're not an L1, we're not an L2. We intend to be an infrastructure layer for the whole web to provide FHE computational services, similar to the way you think Chainlink offers Oracle services for a large portion of Web3. We endeavor to be offering FHE computational services as an infrastructure layer. Um, Specifically, if you want to start with DeFi, the tricky thing in developing FHE, because it's so new and because it offers true encryption and storage, like I talked about, data being it's stored and transmitted and processed, is that um, so in Web3, famously, we have worse privacy standards than we do in Web2.
Mm.
And everyone knows that. And Vitalik's talked about this. Every KOL has talked about it. People in working for traditional companies in Web2, big companies know that. One of the big issues in the last bull run was Nike, Adidas. They were worried about vampire attacks. They're like, wait a minute, if we drop an NFT to hundreds of thousands of Nike users to their wallets, now it's a public ledger. So all of our competitors in Web3 or Web2 can now see our client list, our customer list, and they can start airdropping the same thing and pull those customers away from us. So there's a huge privacy problem, and everyone knows it. But at the same time, if you come out and say that you are a privacy-centric project, you attract a lot of heat and bad
Mm.
attention from regulators and hostile regimes around the world. So it's this thing where everyone knows privacy is a problem, but you can't be solving for privacy in Web3 because you'll get a brand. But the other real benefit, the primary benefit of FHA is really security, because we're talking about whoever wants to encrypt the data. Even for a big infrastructure provider like Chainlink, they can still use FHE, and they're not necessarily delivering FHE as a tool to all of their users, but they can use it for better security on their side, for their Oracle network. Any project in Web3 that's kind of centralized because they're offering core services and they haven't. Decentralization is a process. You can't just start instantly with decentralization. And we're seeing, especially now, organizations that do think decentralization has to be, the target at all times. We find famously it's really hard to organize then, because you have different stakeholders, everyone has a different opinion. You can't get directionality because you can't create consensus. So for a lot of those providers that are kind of have more centralized offerings but necessary critical offerings, FHE is still valuable. So in the world of DeFi, we were productizing, kind of bridge solutions and hiding transactions between senders and receivers, and where you could hide the sender EOA, the receiving EOA. And it was a great product, and DeFi projects loved it. Users loved it. And then, about a year ago, in about a month, we had these three things happen. Vitalik's privacy project called Nocturne, which had just raised millions of dollars of funding 6 months prior, totally shut down, and he announced it was shutting down, which we could only surmise was because he was getting heat from regulators around the world. Then the founder of Tornado Cash's home was raided, and then Binance delisted Monero and Zcash, some of the two of the most famous privacy chains. So those things all happened in a really short order of time, and we saw the writing on the wall, and we're like, okay, we don't want to go that route. We're developing something that has a much bigger potential than ZK, and we don't want to get snuffed out before we have a chance to really breathe. So we kind of pivoted more toward a B2B solution, just to offer security for more like infrastructure players. And so that's kind of how we decided to be an infrastructure project. And so we still have a lot of work a lot of products we could bring to market for DeFi, but right now we focused kind of just on restaking as the subsector of DeFi, which is capital efficiency and restaking. So the ability to bring FHE to consensus of LST LRT protocol. So this is one of our core use cases. And so just to describe this a little bit, the jump off point from Web 2 to Web 3, one of the critical differences is decentralization. You don't have a single decision maker anymore. You have a network of validators or nodes that have to come to consensus to verify every block. Okay. And there's other data they have to verify too, which we can talk about in AI in a second. But validators and nodes, if they're all coming to consensus in a public state, and you can see all of this, you have front running, you have MEV, you have bad actors that come in. Now there are standards in place to prevent that, like slashing and time bombing, of course, and those work in sufficiently decentralized networks like Ethereum. They're sufficient for now. But for every other L1 or L2 that comes along, that has a limited set of validators and nodes in the beginning. Sometimes they have 20, 30, because they have to have trusted node providers. They don't want bad actors, and they limit who can come in and be a validator. If you can create a shared private state in which all of those actors do not show their computation for every block publicly, if you can encrypt that with FHE, which means it's encrypted on chain, it's verifiable on chain, which is different from ZK. We can get into that. It's kind of more advanced than ZK for a number of reasons. You also reduce the attack vectors by which a bad actor can attack the network. So you can prevent front running. You can mitigate MEV, and you can make sure that you can also make sure everyone has to do their own work. So in insufficiently decentralized networks, you do have bad actors that come in and just copy the lead validator. There's ways to find out, okay, this validator is staking all these tokens. That means they have a lot of capital, which means they have a lot of access to compute, which means they're most likely to get this answer correct, or to answer it correctly, to get the bid to answer it. I mean, you've got a number of ways that they can copy other validators. And so we reduce that basically. We reduce that attack vector by making sure that it's all a private state. You can't see anyone else. It's kind of like proof of work in a different way to think about it. You're ensuring that everyone who's validating has to do their own computation.
Mm-hmm. In fact, as I was reading about FHE and my network just prior to our chat right now, this was one of the thoughts that came to my mind instantly. MEV and front running is something we also battle with at Aarna Protocol. We launched the crypto world's first AI quant tokenized structured product, and essentially our tokenization platform takes predictions from a deep learning model, and the smart contracts undertake all the transactions, being composable with multiple other protocols. And initially, as we were testing it, we clearly realized that front running is such a massive impact in terms of how this could work out. A lot of crypto bros, of course, pass off MEV as a market mechanism. It clearly is not. And as I was reading about FHE, I was just wondering if there is a way this could actually fix the
Mhm.
problem of MEV and front running in some form. And it's very interesting that you spoke about that as well. So, has there been any real application of it? And I mean, right now, the safest ways are running transactions through private mempools, dark pools. But
Mhm.
is there a, for DeFi protocol, for example, is there a way to have a FHE layer and sort of pass these transactions in a form which will prevent the transactions from being front run?
Yeah. Yes. Absolutely. So I guess there's two ways to respond. I think the first one is that again, anywhere where you need to have a consensus achieved, if you create a shared private state right off the bat, you're preventing front running. We have created a FHE bridge whereby, so a lot of people don't know, and I didn't know until we started productizing here, but every single bridge that happens, either whether it's Swift, the Swift payment system in traditional finance, or whether it's bridges in Web3, there's actually a
Hmm.
message that goes out first that initiates a transaction. There has to be there's a comm line, right? And so in the Swift network, that comm line is heavily encrypted, obviously, and there can be multiple banks or entities that have to participate in a transaction, and so data is being encrypted. The is being encrypted so that no one can see it until they get it. No one can see it in transmission. The same is true in Web3. So you can encrypt that messaging layer and thereby make sure that none of the nodes or validators that are necessary to complete the transaction actually see the raw data. So that's a solution right there, and that's active. That's something that we've productized already. Another area of interest you mentioned, dark pools in crypto are, I think, going to be a they're going to get a lot of attention, I think, as TradFi really starts coming into the space, which now it looks like regulation is going to happen in the States this year. And so the rest of the world will start to follow those that weren't already leading it anyway. Singapore is a market, I think, that's probably the world leader right now in terms of regulation for crypto. But in other markets that were waiting for the US, when we see that regulatory framework be surmised, we'll probably see this kind of draw on dark pools. So the problem with right now dark pools in crypto is they still operate with like the same trust
Mm.
assumptions as centralized. Like unless you can find a way to do the order book matching in an encrypted way, because everything's on a ledger in Web3, you have to rely on the trust and the discretion and the privacy of the provider itself. So SFox or Kraken, their dark pool, for it truly to be like a Web3 product. You can add FHE to encrypt the matching, the order book matching, and so that way the dark pool provider is actually not seeing the raw data, so you don't have to trust them. It becomes trustless. They're not seeing the raw data. There's no single point of attack or single point of failure, and this is kind of a huge, I think, solution that will need FHE over the next several months. So we'll see. I mean, we're keeping our eye on that. Early on, when the VC community saw our project, that was one of the first things they said was like, "This is going to be great for dark pools." We've just kind of needed regulation, I think, to really start productizing into that area.
All right. So, what are the few core areas where sort of my networks application is in practice right now?
So the first one, AI, is definitely where we've productized the most. It started with
Mhm.
BitTensor. We were early contributors to BitTensor over a year ago. We saw this problem in BitTensor, which is a problem I think rather common in Web3. Getting back to this idea of consensus always has to be achieved for a Web3 function to be executed because there's not a single decision maker. And in BitTensor's network, in their framework, what you see is a layer of miners who are hosting models, typically AI models, and then you have a layer of validators who rank and verify those models and how well they're performing. And what we saw was kind of rampant conflict of interest and bad actors. So what we saw in the first example was miners that were hosting a model were jumping on the validator side to rank their own model. Obvious conflict of interest there. And there was nothing stopping them from doing that. Every single subnet had to figure out a way to solve this problem, but Tensor didn't solve it. So the more subnets we went and talked to, the more we got validation that this is a major problem, and they weren't telling anyone. And it wasn't a huge problem yet because there weren't a lot of users, but they knew it was a problem of the very near future. The second problem we saw was that there were no safeguards in place at the validator level. So these validators were all copying each other. If you saw a validator that had a lot of capital, was staking a lot of tau tokens, again, signifying they probably were going to get, to answer, the proper computation for that block. They were just copying the lead validator. So that's called a lazy node problem. So applying FHE, we create a shared private state for the validators as well for the miners. So now this was preventing the miners from just going on the validator side. It also prevented lazy nodes from copying other nodes. So that was our first foray into AI. Then in the late fall, when we saw virtuals and single AI agent ecosystems launch, this whole movement has been in line with a kind of narrative that picks up from Web 2. What we're learning is we're not ever going to stop sharing. The trajectory of data sharing is going up in like an S curve. In order for us to get AI that we want to use and apps and soft apps, whether they're D apps or Web 2 apps, it requires more data sharing on the part of the individual user. We have to share more data for these things to work. That trend is not going to stop. The problem is when you look at agents, particularly multi-AI agent ecosystems, which I think is probably what's going to win over a single agent, because the difference is that one single agent right now is not very helpful. It's too dumb. It hallucinates too much. It's going to take a long time for a single agent to drive real core competency in any particular niche. What's more likely is a swarm of several agents, dozens of agents that can create a core competency. They can run ideas off each other. They can prompt each other to get the best feedback. They can make, once they have access to making their own API calls themselves, and they've got the API tooling to do that, these swarms are going to get really smart really fast and actually be able to take workload off of people like you and I that really don't want to be writing our own code, don't want to be doing our own marketing, don't want to be doing our own BD, don't want to be doing our, code refining, all the things we have to do. So in those environments, that's, I think, the most likely for AI to be useful. That's an incredible amount of data sharing. You've got prompt data that's going into these swarms. You've got all the calls they're making, the consensus that they have to come to before they come back to respond to a prompt. They're going to have consensus among themselves to say, okay, what do we give the prompter back, the inquirer? What's the best answer out of all the answers we got to execute this task? So there's a consensus level there. That's valuable data. So there's an incredible amount of IP in all of these swarms and all of these agents. Again, the S curve of data sharing is going up. And so we wanted to, allow for swarm developers, model developers, AI developers to have some IP around what they develop, to be able to punch up and really compete with Web 2 AI products. We think that's really important. In Web 3, we are perpetually the little guy. We are David trying to fight Goliath in our productization because we're fighting centralized AI developers and servers, which have a lot of data and a huge head start. And also, we want to protect the user. So a lot of information is going to be shared about you. I mean, you have to give a lot of data through prompting in order for these agents and these swarms to be effective. So we're working on that as well. So training data, inference can be protected with FHE. The consensus of these agents can be protected with FHE. All the prompting, all of the calls that they make, we can protect all this with FHE. And we think that that's the only path forward that any of us really want, right? Because what you're also talking about in Web 3, not so much in Web 2, but in Web 3, there is a lot of work to actually completely untether AI from human oversight writ large. So what we mean by that is these AIs now, they don't need to have a bank account. That's kind of a barrier of entry right now because AIs can't make a bank account. They can't get an EIN, social security number. These are all things you need to make a bank account, like a tax ID. But in crypto, you don't need to have any of that. You can just spur up a wallet. And so now you can actually spur up a wallet. You can do some posting in Reddit, Twitter, whatever, and you can build a following, and you can have people send the wallet money, and you can fund yourself. Okay, so that's checked. Now they're autonomous financially. If once the API tooling gets sufficient, and there's a lot of smart folks working on that now, they won't have to have accounts to make API calls. So we're looking at a future, a very near future, where these swarms and these agents have almost no human oversight. Once you launch them, they are now immortal and they can operate. So in those situations, we do want to have some human in the loop. There has to be a way to shut them down if they go rogue. There has to be a way for an individual or a group of individuals to benefit from the economic productivity of that swarm. We don't want these just to be making money for themselves in a wallet that they control. Um, because what's the point then? The whole reason that we're in Web3 is to distribute the economic rewards of technological development more evenly. If we all only use Microsoft and Amazon and Google and these products, all the value accrues up to them, not us. One of the big reasons we're in Web3 is so that, imagine if everybody that was using Facebook in 2004 got a share of Facebook. I mean, that would be hundreds of millions of people today that would be, financially wealthy. That's kind of what we're looking at with with AI today and crypto is everybody can participate. It's like having stock, private equity stock in a project 10 years before it becomes a multi-billion-dollar, trillion-dollar entity. So if you want to have those proprietary features in place that allow people or groups or DAOs to own these things, FHE is really important, and to protect all of the data that they're handling, which is a massive amount of data.
Mhm. That's fascinating. So, in effect, in a world where we'll have multiple autonomous AI agents collaborating together, solving certain specific problems, the role of FHA becomes crucial because the sharing of the data sets on which these multiple agents will be trained, will be inferencing, that data set needs to be secure, securely transmitted, encrypted, transmitted, and even the computation happens on the encrypted data as well. So all will that is that's how I understand it. B, if that's how this the whole transaction value chain will be, the demand for computation on more complex encrypted data is it going to be much more higher, so we'll need yet more brute force computation, or how will that work?
Yeah, like I said before, so you can scale computation with the hardware or with the software. So yes, you will need more computational resources. The question is, how fast can we get the schemes? How much can we optimize the schemes to handle that computation? And the question is, we don't know yet. Our team is doing some stuff in house. It's a little bit proprietary to optimize the schemes so that we don't have to wait. But at the hardware level, you've got companies. These are regular SaaS company or hardware companies like Optalysis that are working on optics chips, probably coming to market in 3 years. These chips will perform FHE computation in light, which when I heard that the first time blew my mind. Like, so coherent light, think of like a laser, they can perform
Hmm.
computation in light and they can do it wicked fast. So we're looking at 1,000x faster than what we have today in probably a few years at the hardware level. So that will be able to handle a lot of FHE computation, sufficient for most applications in Web3, if not all. Um, so yes, you will have the more demand you get. Right now there are not a lot of FHE providers out there like us. There are other L1s and L2s. Like Phoenix is a really great L2 that will just be basically from the Genesis block of that blockchain. We'll have FHE computation, uh, available. We'll have bridges. It'll start to be more unanimous in bridges. So the computation will scale, but the hardware is scaling along with it. And like I said, this people like my product team at my network are scaling the schemes in this on the software side.
Hmm. Okay. Okay. This is all extremely fascinating and interesting. What's sort of what's one of the sort of most exciting achievements or milestones that you've hit at my network, which that you'd like to share with?
Well, we I like to see. So I talked about some of the products that I'm really proud of that we've already shipped. So we were the first FHE project to go public mainnet. That was really
Hmm.
exciting. There's a handful. There's just a few FHE projects that are looking to launch a token this year. We're one of them, and so we should be one of the first in the world, which I think is really exciting. We've had to pivot so much on product to sort of it's like a game of hot potato with regulators around the world. We have a great product, and then we have to pivot. And so the team has just been so responsive to the regulatory climate. and it's been a really tough. The last 4 years have been really hard to build, and so I'm proud of the team. It's an incredible group of people, our product side, that they're able to do that. So I'm proud of that. Um, I think that AI is really. I think that with our AI productization, what I'm really excited about is I see agents as the breakout use case for Web3. Um, and what I mean by that in this, and that's not really a hot take,
Hmm.
but what's to add some nuance to that, in the first bull run that I think most of us were paying attention to in 2017, that was the bull run of um, that was really the bull run, I think, of like people understanding what Bitcoin was. Okay, Bitcoin separates state from money. This is a radical idea. It's controlled inflation. The problem was that there wasn't a pressing need in the world for that at the time. Some of us thought there was, but most people didn't buy into that narrative that like we need to convert to a Bitcoin standard now. People just saw the idea. So Bitcoin in that first bull run was kind of solving this problem of broken money, but the world didn't come to consensus that that was needed right now. The second bull run, the last one, I think was really DeFi. Something like it was the bull run of DeFi. Like, hey, there's a better way to do finance. There's a more inclusive way to do finance. But again, that was a narrative that most citizens around the world, internet users, didn't agree was a pressing problem of right now. AI, I think a lot of people, a critical mass of users, internet users around the world, buy into this idea that it's a critical problem because they've seen OpenAI stealing a lot of data. They're getting sued by guilds and by states and by all these people that they scrape data from. They're seeing the private sector, public sector coming together using AI to censor people and surveil people around the world. So AI, I think, has got a better. More people believe that AI is a pressing problem, and AI built on crypto rails solves the problems. So we have more people aware of the problem. More people agree that it's a major like defining problem of our generation. And crypto is where the solutions are found. Web 2 development of AI exacerbates these problems that everyone knows we have, that a critical mass of people know we have. So when I say that I think that AI is this massive opportunity, it's like this is our chance to kind of show the world that we're building ways to increase individual sovereignty, to keep governments from overreaching, to keep the private sector from overreaching, and to stop oligarchies. It's a pressing problem of today, and we're building those tools. And I think we have a number of partners that we're so excited about, like Zero Gravity and Swarms and Virtuals and AI 16Z and AI 16Z. If you're not, I think recently it came out. They've got the most visited Git book in the world. So people get it; they get the problem, and I think this is a chance for Web3 to shine. And we can stop calling it Web3, hopefully, in the next couple of years. Let's just call it the web.
You spoke about multiple sort of milestones in that, and I guess you got one major one coming up, which you spoke about, which is the launch of your token. So, uh, one of the things I do on this podcast at Nash is celebrate with another founder over a drink, something that is really meaningful for them in their journey. So which one is it that you'd like to celebrate today?
Yeah, eventually when we launch a token, I think that's something worth celebrating. Yeah,
All
for
right, so
sure.
let's toast to that in advance. Well, I was just out with my wife for dinner at a Japanese restaurant, and we had a nice sake. So we ended up getting a bottle of that back home, and I just poured a little bit for myself. So I'm having some sake. What about you, Chris?
Yeah, I have a little bit of tequila here with you, my friend.
All right.
Why not?
So a toast to the token launch.
Cheers.
Cheers. Right. Chris, you guys. Also, I understand in establishing, building up my network, you got two Ethereum Foundation grants, which helped you um, sort of take forward the technology, the build. So talk to us about it. How was that experience? And I'm asking this question in the context of everything that's happening with the Ethereum Foundation right now. And
Mhm.
we really, I mean, a lot of us have deeply believed in Ethereum as really the most decentralized stable network on and the decentralized network on which multiple applications will be built on. How and we seem to be at this sort of a fork, and the foundation has a very important role to play. What do you have to say about your experience and where we are right now?
Yeah, my network is an Ethereum native project. We have received 2 grants. We won the ETH Singapore hackathon. We're very active in the community. We're very happy to see the launch of Etherealize, Ethereum's kind of BD arm. So we're trying to work with that team and Vivek Raman and bringing solutions to their partners. And it's been a very helpful. Obviously, it's got the most developers, that ecosystem. So we've had no shortage of projects to productize for, which has been really helpful. I think, especially in the early stages. Um, Vitalik is famously really concerned with this issue. He wrote a paper about FHE a few years ago. He's been talking about privacy in Web3 and this kind of obvious idea, which is that if Web2 became Web3 today, all of your SaaS subscriptions will be on a public ledger, your
Mhm.
grocery bill, everything you do. And that's just simply not acceptable. So, like I said at the beginning of this talk, everyone knows that the privacy standards are not there. We need better privacy, but we also need better security that can beat Web3. Any place that we can get an advantage in Web3 over Web2, we need to take it because we're competing. I think we're competing with Web2. These two industries are still very bifurcated in terms of capital. You have Web2 allocators and Web3 allocators, and very rarely are they the same. You've got relationships with regulators that Web2 has. Web3 doesn't have those relationships. You just have a lot of really young, hungry, ideological people in Web3. And so any advantage we get, we need to take. And so security is one of them with FHE. And we were excited to see Vitalik's been excited about that. A lot of people, every DeFi protocol we've talked to in the Ethereum ecosystem is very excited about what we're building. So I'm excited to see what they do, what Etherealize does. And I think that there are already some leaders in the space. Like Chainlink has done a really great job trying to onboard the next billion through traditional banks. They've been working with big entities around the globe for a really long time. They've got great relationships. So I think probably Ethereum Foundation is maybe not at that level, and they could look to that as a North Star and what Sergey's been able to do there. But we're going to be helping Etherealize as much as we can, because we have products that are needed for TradFi that we think will appease regulators and that will allow individual users better data sovereignty and more security in all of their Web3 activity.
Mhm. So you're very optimistic about where Ethereum and the Ethereum Foundation's role evolving, especially when they're looking at more product focused approaches with Etherealize, for example. How so I gather you're much more optimistic than most.
Yeah, still, I think some of the bad press that Ethereum's got in the market, I think, is just because this has been a weird market as well. One of the things about it, I still think with the ETH ETF, the fact that Ethereum's been around for a while, um, tenure matters to TradFi into Web2. They want to see a project that's been around a long time. Ethereum's been around for a
Hmm.
long time. It's got a lot of trust already with those institutions. I think people are just really upset about the price, which I think has a lot to do with staking rewards having to be higher than yields. So if you are a traditional investor, which I think is Ethereum's target demographic, it's a big part of their demographic. If you can have a treasury bill that's giving you more yield than Ethereum, the treasury bill is more risk off. So if rates come down and you kind of get that below the Ethereum staking yield, I think that's when ETH gets the big bid again from where it's traditionally been getting that big attention bid, which is traditional capital markets. So that's going to be a catalyst for price. I think that's coming at some point this year, and then people will be all happy and start writing about Ethereum again. But the fact that they took, I think they took the cue from the market, which was like, look what Solana did.
Mm.
They weren't as focused on decentralization. They just wanted to make a sleek UX, fat. They want to give people what they wanted, and it's worked. Solana is now caught up or is beating Ethereum in a lot of metrics. And so I think Ethereum took the note, and that's why they launched Etherealize. And so they're getting serious about it. So I'm bullish on the ecosystem.
Hmm. All right. I mean, in the area you're in, clearly, and we touched upon it briefly, including how you pivoted to infra, this whole gamut of the regulatory framework. How do you see that evolving as well in terms of privacy on blockchain?
That's a great question. So we've set up an architecture similar to BitTensor, not the same. It's got some different incentives, but if you look at BitTensor, they have a number of subnets, and every subnet is basically a different distribution of AI and crypto. What we've done is also we have subnets. We call them hubs. Every hub is sponsored by a partner, and
Mhm.
it features a different distribution of FHE for data protection. And so this is it's a really broad range. We have partners in Deepin,
Mhm.
DeFi, AI, the different subsectors of AI, AI operating system with zero gravity, helping them encrypt their memory, single agent with virtuals, multi agent with swarms, da 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 da. Um, we're looking to eventually maybe RWA if there's something that can be done there, but we have 4 or 5 serious verticals in Web3 that we're already servicing, and so we just hope to keep kind of building out the subnet so that we eventually have hundreds. And so we're launching roughly 1 to 2 different hubs every single week, and by the end of the year we will have dozens and dozens. So all of those are different use cases. We do have an internal chain we had to design this on purpose. If you encrypt with FHE, as we talked about in this discussion, it's computationally intensive, and you also have to decrypt with FHE if you encrypt with FHE. So to keep that all in house, we have an internal chain, and we are able just to produce the result, which people just want the result of FHE computation. They don't want to actually have to run it on their side at all or do a lot of integration. So we've kept that lift really, really light for a lot of our partners. In a lot of cases, it's just kind of it's a really simple technical. There's no real integration. We do it all on our side. It's just some co-marketing, some incentives for their users as well as ours to kind of get the hub up and running. But most of the hubs that we've launched so far sell out really, really quickly, because it's if you're a retail user and you're just kind of an investor trader, it's kind of nice if you can make one allocation into a project and maximize like 2 or 3 different narratives. So on the one hand, we've got the security narrative, which is big. We need a lot more infrastructure security, but that's a little boring, I think, to some users. So you also get the AI narrative or whatever the narrative represented by the partner who's hosting the hub. So it can be Chainlink. Maybe you're bullish on that. It can be Swarms. It can be IONET
Mhm.
on the GPU side. So you kind of get exposure to multiple narratives by having one token. So we've seen that really bootstrap the community well. We have over 1 million active wallets. I think we're approaching 1.5 million active wallets. People tend to really like that.
So, so in effect, if I were to look at it as an application, let's say for a protocol like Arna, so we've developed this feature set on which our proprietary model Alpha 37 deep learning framework is trained on. And what I'd like to do going ahead is uh, really open up this feature set, which is one of the real IPs we have in some sense, to other data scientists, to other AIML folks to come and work on this feature set and be able to uh, develop alternative models like our Alpha 37. Now, is this a use case where a protocol like Arna could be a hub on the my network and be
Mhm.
able to open source the feature set in a secure form where the IP is protected, but at the same time it completely opens up for decentralizing in some sense the multiple AI agents to kind of work on that data set.
Exactly, 100%. And I think this is a good opportunity to get into the difference between the encryption schemes that everyone's using right now, because what you're defining could be used nicely with ZK. The problem with zero knowledge is that the entity that's running the zero knowledge proof, that's running the computation, sees the raw data. So there's a trust assumption there. The second problem is that only the proof goes on chain. And so there are ways to make sure the proof is sound and that infrastructure is reasonably built out. But you still are working with a proof. With FHE, you are able to do the computation on chain, keep everything on chain. There's no one that sees the raw data. Even the person running FHE, even us, we don't see it. So you can retain IP, and you do have the ability to decrypt it. And we have some multi-party computation baked into our framework as well. So if you do decide that you need to see it at some point, or someone wants to, or you want to white label who can see it in a sense, you can do that as well. So there's a lot more optionality. There's better security because no one sees the data, and it's all verifiable on chain. So those are kind of three advantages to doing it with ZK. So everything every advantage that you just spoke of would be actionable launching a hub on my network.
All right, fantastic. I think that's something that we'll certainly explore. I touched upon regulation and how you might perceive certain headwinds there. Um, when you talk about encryption, and we spoke about that, we touched upon that very briefly earlier. So, how do you see it right now, or in the infrastructure play that you have right now? There are limited areas where there may be friction with regulation.
Yeah. So regulators, so far from our experience, um, regulators, traditional regulators, actually don't love ZK because, again, the raw data is being exposed there to a processor. So you can do it, but then that processor, that project, that company that's doing it, needs to get SOC 2 Type 2 and all the things that a regular centralized company has to have, creating a central point of failure. They'd love to see that project become just a regular incorporated company in the United States, in Delaware or Wyoming or wherever. So that kind of goes against the Web3, ethos. But with FHE, it's verifiable on chain. We don't see the raw data. So, we're still kind of in the early stages of working with regulators. We think that relationships will be important. There's a lot of activity happening now. So we want to make sure that they get the right ideas about FHE. So I'm doing a lot of work to make sure that happens and we don't get the wrong brand, associated with us. But, broadly speaking, it's kind of a regulator's dream because the issue has always been the decryption portion. When you're processing data, you have to decrypt it. Someone's got to decrypt it. So this is a dream come true for regulators. It's a dream come true for individual users to be able to kind of process it without decrypting it. So that's the messaging that we're going to be sending when necessary and when appropriate. We don't have to go on like a big regulatory tour. That's kind of one of the benefits of Web3 is like get some users, and once you have enough users, you'll have market demand for something, and market demand is what eventually forces regulators to make a move, unless they want to completely work against their constituents. So, yeah, I'm hopeful.
All right. Chris, this has been a fascinating conversation, like I already mentioned. You guys have spoken about encryption as sovereignty. What does that mean? And let's end with that.
So, yes, I think that the future is more digital than it has been and than it is now. We're going to be living more of our lives in the digital world, and I don't mean that in a bad way. Touch grass, be in nature, all those things. But a lot of the work, an increasing amount of the work that we do as humans, has been online, through software, through the internet, through applications, and I think that just creates a world of more data sharing. And so we need to start looking at data as this fundamental human right. And we need to start protecting it that way. And so FHE is critical for that. I think a world in which we don't have if we can't treat data as property, if you can't get that classification of data, then anyone who has access to your data can know a heck of a lot about you. And people, I don't know yet if we've had a lot of stories about data breaches, privacy breaches, and private sector, public sector collusion around our data. But what a lot of people don't know is like Meta, for example, launched this program where they created a version of you, an avatar of you based on all the data that you share on Meta platforms. And then they had an algorithm send your avatar advertisements for different products to see what you would be most susceptible to. And then once they had a compelling set of products that your avatar would respond to, then they send it to you on Facebook. and that's how they increase sales. And so there's an incredible amount that can be determined about you. You know, the way that you, even the way that people write, like the way that we write, like compose online. You know, your
Mm.
grammar, your style of writing. There's a lot that can be inferred from the way you write. Whether you're a happy person, cynical person, whether you might be on SSRIs, whether you might be that, you know, there's a lot you can infer just from that. Let alone if they can get birth date information, the place that you came, the place that you were born, and where you live now, and your monthly bills. So we really need to start looking as like data is synonymous with privacy, because if anyone with access to your data can infer more about you than you can even infer of yourself, especially with the more advanced AI coming around, it's like knowing how to trigger certain people to get them to take certain actions is something that we would think of as like a psychologist or a psychiatrist can do. AI is like 1,000 of the best psychiatrists in the world. And so companies with access to that level of AI can encourage you to do things that you wouldn't normally do and that you wouldn't even discover that you're doing until months into this kind of behavior pattern that you've created. So data really needs to be protected. I think at the user end, we need to offer more tools for that. We need to make it so that less of the people that are processing our data in order to give us the products that we want see that data. It's synonymous with sovereignty. And I don't think there's a future that any of us want to participate in that doesn't include it. So I think this is one of the great battles of our generation and of our time.
Christian, lovely having you on Alpha Unhashed. Thank you.
Thanks so much, Sri. It's been a pleasure.